All right, we're starting Unit 4 today. We're going to break up Unit 4.1 into 3 days. Today we're going to be looking at just the beginning of 4.1. We're going to start by talking about power functions. Now, a power function is any function of the form f of x equals a x to the n, where a and n, the only thing about a and n, both have to be, they can't be zero, and they have to be real, so no imaginary numbers there. For a power function, a is what we call the leading coefficient, and n is the degree. All right, so leading coefficient, degree, those are going to be huge terms that we're going to definitely need to understand. Leading coefficient is that first number in front of the x. The degree is the exponent that is above the x. And the degree is the value of the exponent. A power function in which n is a positive integer is called a monomial function. All right, so as long as our n is a whole number, so no fractions, no decimals, and it is positive, so it's a positive integer, that means that we would have a monomial function. So if you look at the leading coefficient, if our leading coefficient is positive, then we are always going to end on the right side. Our graph will be going up towards positive infinity. Now, depending on the degree, the left side could be going up to a positive infinity also if it is even degree. So if our power is 2 or 4 or 6, then that would have a even degree, so that both ends of the graph would be going up to a positive infinity. But if we had an odd degree, so a power of 1, like a linear equation, or a cubic function like 3, or quintic function like 5, or 7th power, or something like that, odd numbers, then our end behavior as x goes towards negative infinity, our f of x will be going towards negative infinity as well. So if our leading coefficient is negative, so it starts with like a negative x squared or a negative 2x to the fourth. All right, so if it is a negative leading coefficient, then our right side of our equation, so as x goes towards infinity, will always be going towards negative, our f of x will always be going towards negative infinity. However, if the left side varies as well, just like the positive, but in the opposite way. So if it is even, so x squared, negative x squared, or negative x to the fourth, then both sides of the graph would be going down to negative infinity. So as x goes towards positive infinity, f of x is going towards negative infinity, and as x goes to the left towards negative infinity, f of x is going down towards negative infinity as well. If it is an odd degree, so again, x to the first, x to the third, x to the fifth, something like that, the left side of the graph would be going up towards positive infinity. All right? And so our domain and range for all of our odd degree functions are both going to be all real numbers. In fact, the domain for all monomial functions is all real numbers. The range is limited only on even degree functions. So if it is an even degree monomial function, the range, if it is even and the leading coefficient is positive, the range is going to be all real numbers greater than or equal to 0. And the range for all even degree negative leading coefficient function, monomial functions, the range will be all real numbers less than or equal to 0. So odd degree monomial functions always have at least one real 0. Even degree monomial functions may have any number of real zeros, or in fact, no real zeros at all. The end behavior and degree of a monomial function, this is how we could describe it. All right, so we could describe the end behavior of f of x equals negative 2x cubed. Well, the first thing we need to look at is the leading coefficient. And the leading coefficient is this negative 2. So that is our leading coefficient. Our degree, we look at the exponent it's raised to. So our degree is 3. The domain for all monomial functions is the same. It's all real numbers. So you could say all real numbers or you could say from negative infinity to positive infinity. And our range, since our degree is odd, our range is also going to be negative infinity to positive infinity. Now, in behavior, our leading coefficient is negative. So as x goes to the right, our f of x is going down to negative infinity. And since our degree is odd, that means that as x goes to the left, it's going to do the opposite. So it's going up to positive infinity. Odd for opposite. All right. Think about the right side first. Our leading coefficient tells us about the right side. Left side, if it's odd, it's opposite. Okay. So now we're going to talk about how to graph a power function by using a table. So for water to flow through a garden hose at a certain rate in gallons per minute, it needs to have a specific pressure in pounds per square inch, PSI. Through testing and measurement, a company that produces garden hoses determines that the pressure, P, given the flow rate, F, is defined by P of F equals 3/2 F squared. So we're asked to graph the function P of F and state the domain and the range. So step one, we need to identify the A in the degree. The A is our leading coefficient. In this case, that is 3/2. And our degree is 2 because it is raised to that second power. Now, our domain, again, is going to be negative infinity to positive infinity. And our range, this time, is going to be limited. It is a monomial function, and it is positive A, so that means that we're going to start at 0 with a bracket and go up to positive infinity with a parentheses. So now we can create a table of values. Most of this table is already created for you. If you did not have a table created for you, it's very easy to do so. You just pick random values of your input. In this case, our input was f, and then run it through our function P of f to get an output. So if our f was -2, our P of f would be -2 squared, which is 4 times 3/2, so that would be 6. If our f was 0, 0 squared is 0 times 3/2 is 0. And if our f is 1, 1 squared is 1, 1 times 3/2 is 3/2, or 1.5. So now that we have some ordered pairs, we can graph those ordered pairs and make a parabola. All right, so we have ordered pairs at -2, 6, -1, 1.5, 0, 0, 1, 1.5, and 2, 6. The other points, 3, 13.5, and -3, 13.5, those are going to be off the graph. So now we're just going to connect these points with a smooth curve, so not like rigid lines between them. And we know how to graph parabolas. We've been graphing parabolas for months now. And so our function looks like that. All right, so it works the same way regardless of what the power function is. So whether it's a fourth power or fifth power, we just figure out what our input is and take it to that power and then multiply it by that leading coefficient, and that will give us our output. All right, hope that was a great short lesson for you. If you have any questions, shoot me an email or a Canvas message, and I'll get back to you as soon as I can. Thanks. Have a great day.